Okay, folks, so today we're going to make a potentiometer control a LED, like how bright one is. So we're going to need an Arduino. Oops, there we go. We'll definitely need that. We're going to need a breadboard for the LED. And we're going to need a, let's see, resistor. Just go back to some basic stuff. We're going to need a resistor. And we'll just stick it in here somewhere. I'll just stick it in to, yeah, actually let me rotate it. Rotate it right here. There we go. And you'll need an LED. I'm going to put the positive side right there. So the positive side is there. You can tell because it's the kinked side, it's the longer side. There we go. So we got the LED. And we'll need a potentiometer. Let's see what we got here for potentiometers. Here's a potentiometer. Remember, your potentiometer is 3 wires. I could stick this in the breadboard, but I know the ones in class are not, so I'm going to leave it right here. There we go. And I think this is everything we need. Let's see here. So the potentiometer, if you remember, it's going to have one wire that's going to be the output. It says output here, and it goes out to here. I don't know which one it is on yours. I know on a blank one that goes in a breadboard, it's usually the middle one, but just read it, see which one is the output. It's going to go to A0. And one of these, I don't know which one was which, is going to go to ground. I think I'll go to this ground just to make it nice and neat. And one goes to positive. So right there. And only one is going to have the signal that goes to the analog input right here. And once you set that up, we're also going to need an LED today. We have to use one with a squiggly line on it. So I don't think pin 7 will work. Unless yours does have a squiggly line on it. We're going to use pin 11 for now. If yours is also that, then you can do that. So that's going to be pin 11. It goes to the resistor. It goes to the positive side of the LED. All right. The negative side of the LED, just send it to ground. So I'll just send it here. Then I'll send this to here. You can go directly to the ground if you want. I'm just trying to make it nice and neat here for you guys. There we go. So this is going to go here. And you can see this goes here. This goes here, which goes here, which goes here. So there we go. That's ground. So now we're all set up. What does the software look like? Well, we're going to use a software we used before, Arduino, and we're going to use an example, basic, and we're going to go to read analog voltage. We've used that before, and it should pop up with this thing here. Now I'm going to go ahead and delete this code right here, because all this does is there's only like a few lines of code. It just begins the serial port so that we can click this little guy and read. Then it creates a variable called sensor value, and it analog reads A0, that one pin where the potentiometer is. Then it creates a new variable, and it takes the sensor value and it does a little bit of math to convert it to a max of 5. Then it prints that on your screen. That's it. It doesn't do anything except print. So we're going to change this up a little bit. First, I'm going to add an LED. So pin mode. And then I'm going to put pin, I think it was 11 we're using. And then it's going to be an output because it's for the light. Then we're going to say it's going to create a variable called sensor value, an analog read. We're going to keep that. Then it's going to create this variable. We're going to just change the name of the variable to brightness. You can call it whatever you want. And we're not going to make it a float. A float means that the variable can be like point something, like 0.2, 0.3. We just want a whole number so that our brightnesses are 1, 2, 3, 4, 5, 6. And Then we're going to take the sensor value and times it by this math formula. But I don't want a max of 5 volts. I want a max of, do you want to guess what it is? Pause it and think for a minute if you want. All right, well, if you did pause it and you're unpaused now, the value would be 255 because that's how bright the brightness can be. We're going to go ahead and still print it, but please change this because we don't have a variable called voltage anymore. It's called brightness. And then, of course, we needed to light up our bulb. So we're just going to say analog write, and we're going to write to pin 11. Remember, analog write means we can choose how bright it is. Digital write means you just put high or low. Analog write, we put the number, comma, and we put 0 if we don't want it on, 255 if we want it super bright. If we want it kind of dim, you put a lower number like 30. We're just going to put the brightness variable. So I'm just saying, so we're going to print brightness so that you can click here and see what it's actually doing, like what the number is. Should be 255 if you spin your potentiometer one way, 0 if you do the other. Then it's going to write to pin 11 with that number. And it's going to do that over and over and over again, constantly updating as fast as possible because there's no delays here. It's just going to constantly flip through here, checking the analog read on pin 0, which is, let's see if I can find it, right here. That's connected to potentiometer. The out of the potentiometer is going to there. It's checking, constantly checking that. Then it's constantly creating this variable called brightness and taking that value, the one that we set to this, and it does a little math problem to it. So it converts what used to be 0 to 1023. So if you look here, this pin, it reads the voltage that's coming out of here, and it converts it to a number 0 to 1023. Kind of useless for us. So that's why we do a little bit of math problem, and we set it to 255 as the max. And it just kind of divides it by 1023, finds the fraction, and it times it, makes that. Then we print that brightness, because we just created it, prints that brightness. Then it writes to that brightness. And that's it, guys. That should work. And that is all.